So good morning, everyone. We are here once again, and today we will be looking at TypeScript tooling. So in our previous two classes, we took our time to understand TypeScript and how TypeScript works and how we can write TypeScript and make our code more elegant, maintainable, and should I say battle tested, something like that. Okay, so today under that TypeScript tooling, we'll be looking at a couple of things. First of all, we review tsconfig.json, the file that in-houses TypeScript configuration. And we'll also look at development, how we can use some couple of tools to develop projects. Apart from that, we'll also be looking at building and bundling for production. So okay, so I will look at building and bundling for production. After that, we'll look at the tools for building and bundling, which we first of all look at Webpack, look at ESBuild. We'll briefly discuss these tools and which one to use at the moment and all of that. So under tools, we have Webpack, ESBuild, Rollup, Rolldown, and Tears Down is currently the Oga Patapata of them all. And after that, we will convert part of our command line interface application to TypeScript. So it will be an interesting class. So while we are going through all of this, if you have any questions, you can just raise your hand and you'll be allowed to ask your question. Anything or anywhere you get confused at all, make sure you ask questions to get to be clarified. Okay, so first things first, we have tsconfig.json here. So under tsconfig, we'll be looking at the core structure, compiler options, and the basic configuration. You know, it has a whole lot of configurations. So before we do this, let's get our project ready. Okay. Okay, so here is our repository, and we move into our task manager app. Okay, so here we are in our task manager app. First of all, okay. Okay, so in our Task Manager app, we have a package JSON file, and in here we have okay, so we don't have dependencies, and we don't have development dependencies. But right now, we add dependencies and dev dependencies because we want to convert our project to TypeScript. So how do we go about this? So first of all, we will install TypeScript. So this -d here means install it as a development dependency. So essentially, you can say npm I -- serve dev. Then the package you want to install, let's say TypeScript. But the short form for this is if you want to install it as a development dependency, the D will take care of the -- serve dev. So do something like -d, then you see TypeScript. Now, if I hit enter, the development dependencies section will be added and the latest version of TypeScript will be added in the dev dependencies. So we have dev dependencies here and we have TypeScript version 5.8.3. So this is great. So now that we have TypeScript in our project, we can go ahead and say npx tsc. Let's verify that TypeScript is correctly installed. Okay, so it is installed. Now we have a whole bunch of options here. So with this, we can even okay. So with this, we can even go ahead and without even looking at any other thing, you can look at this and you will see that the version is 5.8.3, TSC, the TypeScript compiler, version 5.8.3. Then we have common command, TSC, compiles the current project, tsconfig.json in working directory. Then we have TSC app ts, UTS, ignoring tsconfig.json, compile the specified files with default compiler options. Then we have TSCB, build a composite project in the working directory, TSC, create a TS.json, and all of this. So we have watch input files, show all compiler options. So we can come over and see npx tsc -- is it -- all, not tsx, tsc, not tsx. Yeah, so we can now see all the compiler options. So if there's any compiler option you are confused about, you run that and you will be able to see the compiler options. So we have the target here, set JavaScript language version for emitted JavaScript and include compatible library declarations. So it will be one of ES5, ES6 / ES 2015, then ES 2016, ES 2017, ES 2018, 2019, 2020, ES 2024, and ES next. So if you set it to ES next, any new JavaScript version that is being released, it will be compatible with it. So the default is ES5. Then use define for class fields and all of this. Emit ECMAScript standard compiler, so and on. So now we need to initialize a tsconfig file in our project so that TypeScript will know what exactly we want. So in order to do that, we can manually create it and then write all the configurations. But since we are trying to understand what it is all about, we just do something like npx tsc -- init. So this is, you are telling TypeScript, the compiler, to initialize a TypeScript configuration file. So it's in JSON format. So we are saying TypeScript compiler, please initialize a tsconfig file for me. And now it will go ahead and simply do it. So if I hit enter now, and you see in the root of our project that we now have a tsconfig JSON. So we have a bunch of things in here. Let me try to do this like this. So we have a bunch of things in here. And now we have, as you can see, the target here is 2016. That is a JavaScript language option. It will compile to ES 2016. And then the module here is CommonJS. Specify what module code is generated. So we can change this thing. And you know it's TypeScript, so it is auto-completed. If you type E, then all the options pops up. We have the system now, node next, node 18, node 16, preserve, yes, next. And then if you type C, we have CommonJS. So this is the default, which is CommonJS. And we have the root directory, the module resolution. So the module resolution here, if I comment this out, so I can come over here and remove this. If I type B, you see bundler. So this is the recommended setting in TypeScript version 5.0 plus for application that uses a bundler. And we'll see that in a bit. So if you are using a bundler, TypeScript is not responsible for bundling your project for you. So the bundler you are using will take care of bundling, optimizing, and doing every other thing for you. So if you leave it to be bundler, well, if you type node, then you see other options, node 10, node deprecated, use node 10 in TypeScript 5.0 instead. So if this one is deprecated, we have node 10, node 16, node next, and we have bundler. Okay, let's leave it as node 10 for now. Now we have the base URL. Now the base URL specifies the base directory to resolve non-relative modules. We have path, we have root directories, we have type root, we have types and other things. So I guess we should just start looking at all of these one by one. Now, this is not a TypeScript project, but now we have TypeScript installed. So let's look in our source. First of all, the tsconfig.json file in TypeScript, I will just have to repeat it again before we start all over. I just gave you some examples so as to know what's going on. So it's a configuration file that defines how the TypeScript compiler should behave. So it serves as a project root and contains compiler options. So these are the compiler options. You can see compiler options here. File inclusion, exclusion patterns, and project references. So I may come over here. So first of all, we'll look at the code structure. The code structure, we have the compiler options. These are the compiler options. I'm moving on. If we go down to, okay, these are all the compiler options. So we have other things. We can add things like include a text and array. So in this array, which files do we want to compile? So we specify. So we say let's include everything in the source directory. So everything inside, the files inside and the sub files and folders, everything. So we include this. So which should we exclude? We don't want to compile this one because they are just for development purposes. So which one is that? So the first thing here should be the node modules. And the one we build, the distributed folder, that is the one we use in production. So I guess that's it. But then if you go ahead and run npx csc, okay, so this one is no inputs were found in config file, exclude parts were node, and this. Okay, source. Okay, let's say source slash no, everything in source. So let's do something like source directory, include this. Let's see why I'm getting this error. No inputs were found in config file. Okay, so we're getting that error because we have the base directory. Let's come over here. So the base, specify the base directory to resolve no relative module names. So let's say this slash src. And we don't want to allow JavaScript in our project. So anyway, there's JavaScript, allow JavaScript file to be part of your program. Use the check.js option to get errors from. So we can allow JavaScript and use check.js to make sure, enable error reporting in type check JavaScript files to make sure that any JavaScript file that has types will get an error if there is any misuse or something like that. So we can change this here to ES20. Let's do ES6. So we want JavaScript to compile to ES6. And the root directory here should be src. This is our source. Okay. The root directory is this // that is the root in here where we are actually. That is inside the task manager. That's the root folder within your source files. Or we can, let's say, since we are just compiling the source directory, let the root directory be here so that when Typescript starts, we say, okay, this is where I want to compile and nothing out of this. What else do we need? The output directory should be dist. So once our JavaScript to be compiled and stored into this directory. So if you come over here and say remove comment to true, okay, let's leave this as false for now. Let's clear this. I'll run this once more. Okay, so now we have sanitized string. Parameter input implicitly has an any type. Okay, so we found errors because we've not changed our project to TypeScript. That is the reason why we're getting all these errors. Now, if you open the dist, now we have all our folders, and the dist now serves as a compiled version of the source. So if you open the index.js, now we have the compiled version here in JavaScript, but it's already a JavaScript project, but then it's older version. This is Node version 10 because we specified it there. And if you open utils, you see all of this. So in the TS config file, if you come over here and we say, okay, let me check. We still have comment. So if you come over here and say remove comment, we say remove comment to true. Let's clear the terminal. This, remove the distributable file. Distributable folder. The dist means distributable because when you build it, you can distribute it to anybody to actually just run it on their machine without compilation because you've already compiled it. So we can go ahead and run this one more time. Okay, so now we still have errors, but if you open the dist and you open index.json, now there are no comments. Where did I open? Okay, so we are supposed to have comments here or here or here. But as you can see, there are no comments. So we've removed comments with just TypeScript. So what else do we need? No implicitly any. We can set this to so that our project will be more strict, and then strict null checks. So when checking, when type checking takes into account null and undefined, so that to make sure there are no memory leaks and every other basic things. So there are a whole lot of things here to consider. But I think for our project, this is all we need. Target is year 2016, and module is year 6. Module resolution node 10. Let's change this to node next. Now go ahead and run npx tsc. Okay, so now we've built our project, and well, if you can see, we have the distributable here, and there's nothing. This binary folder is not included because we did not include it in the tsconfig.json. Yes, 6. Node next. Okay. Node. Node next. Because module resolution is node next. Therefore, the module also has to be node next. Okay, so we're cool now. But remember, we're still running JavaScript. So if you want to also compile the binary directory, what we'll come over to the include here, we'll also specify /bin. Now we'll come over here and delete this dist. And let's go ahead and run npx tsc. Now, if you open our dist, you see command index. Okay. Let's check our output directory is dist and the base URL. Directory is also the root. Okay. Let's say this is /. This is the root directory. So that the binary directory will be included. Now let's run this once more. npx tsc. The dist now the dist now has everything, but let's delete it and rerun it once more because it's messed up right now. Clear the terminal, run npx tsc. Now, if you open our distributable folder, we have the source with everything inside, and we have the binary folder with everything inside as well. So this is great. Now you can see how we are configuring TypeScript to do things the way we want it to. Okay, this is great. So now we've seen how we can configure tsconfig. That you can go, you will need to experiment with all of these things, right? You will need to, no emit through disable emitting files from a compilation. So if you set no emit, let's even do this one here. Output file, I say use AMD and system modules are supported alongside that output file. Because in AMD, let's not go out to unified all those modules. Let's just leave this one for now. So basically, this is how we can configure TypeScript. So we already know if you are building for a library, there's a this one here. So specify a set of bundled library declaration files that describe the target runtime environment. So this will help for auto completion and typing. So here you can go ahead and say, okay, the DOM, if you're building for front end, like if you're building for React or anything front end, you need to have the DOM. Then you have the ES 2020, ES 2020. Maybe you only need the ES 2020 big int, date, promise, shared memory, string, or symbol. Or if you need everything, just add ES 2020. Then we have ES next, web worker, and every other thing here, if you wish to. So now if you build your library, the typings for the DOM and ES 2020 will be available for auto completion and the rest. And also for the runtime declaration files that will describe the target runtime environment. This will help TypeScript to compile your project successfully. Okay, so essentially we've seen how we can configure our tsconfig JSON file, but we've not really looked at things. So we'll also look at the path in due time, but for now, let's leave it like this path. So we can configure, should I call path aliases? You will see things like import something like import some package from @/component or /utils, something like this. So we can also do this using this path here. We come over here, we'll say, okay, can do something like this. Say @utils/ everything in the utility folder. So let's check out. Okay, everything in the utility folder should map to let's say utils like this. So now if it's TypeScript utils, so we have this. We have our utils this. Can you see this? Now it's auto-completed and we don't have any errors. So you can even come over here and say, okay, instead of doing this, we should say @/. And then we can come back to our index.json and say, okay, instead of that, let's say @ and then it will be like this @format. And we are good to go. So if you've been wondering how that works, that is how it works. Okay, so we've had enough of this tsconfig something. It's something we will continue learning as you continue from familiarizing yourself with TypeScript. So TypeScript is fun and something to, it's sweet actually. So let's see how we can move forward. We've seen the code structure, the compiler options, and the basic configuration, how we can configure our TypeScript to work with our project. So moving on, we have TS Node and TSX. So what is TS Node? So TS Node is a TypeScript execution engine that allows you to run TypeScript files directly without pre-compilation. That doesn't mean if you're running JavaScript, you're running TypeScript, no. So it performs JIT, just in time. That's the full meaning of JIT. So it performs JIT compilation by hooking into Node.js module loading system. So how does TS Node work? So it uses the module hook. So it intercepts TS file imports. And then second, it compiles TypeScript to JavaScript in memory. You will not see the files being compiled, but it does it in memory. Then three, it executes the compiled JavaScript immediately. So after compiling and executing, it catches compile result for performance. So immediately it compiles and then executes it. It will catch the compiled file so that when next you compile, it will only affect the newly compiled files and then use the catch results for the rest. So I think we should just take a look at TS node. So we have TS node. It's here. Okay, great. So here is TS node. So we can look at the overview. So TS node is a TypeScript. Let me just zoom in a bit. TypeScript is a TypeScript execution engine and REPL for Node.js. So it just in time transforms TypeScript into JavaScript, enabling you to directly execute TypeScript on Node.js without pre-compiling. So this is accomplished by hooking Node.js module loading APIs, enabling it to be used seamlessly alongside other Node.js tools and libraries. So the features of this, we have automatic source maps in stack traces, automatic TS config JSON parsing, automatic defaults to match your node version, type checking, which is optional. This one, REPL, I believe you know this. If you don't know, you should just check it out. Then write standalone script, native ESM loader, use third-party transpilers, and all of that. So npx TS node, we have installation here, npm install -d TypeScript, then npm install -d TS node. So I guess instead of let's do something else. Let's go ahead here. Move out of this directory and then create another one. Let's call this one TS tooling. And let's cd into TS tooling. So this is empty. So let's initialize npm init-y. Now in the TS tooling directory here, okay, we have a package JSON. So we can go ahead and quickly install npm id TypeScript TS node. Okay, so what just happened? You are telling me that if I am behind the proxy, let's do this one. npm id TypeScript TS node. Okay, so maybe it was due to network. So we have our development dependencies here. We have TS node version 10.9.2 and we have TypeScript. Okay, so now we can add scripts here. First of all, let's add a new folder. Let's call this one src. And in here we have index.ts. Let's see. And in here, let's have a folder utils. So this one will be a simple one. And in this utils, let's write add ts. And then we'll export function, add number, return a number, done this. So export export function or base number exponent, and then say math that power exponent. Okay, so that's all we want. And in the here we have export everything from utils add. So Copilot is auto-completing for us, but we don't really need its help actually. So I guess we have the add and we have our functions. So we can even, without exporting, so this is our library that we want to use. So we want to be able to use these ones and do things. Let's perform arithmetic operations so we can install our TS. So let's create a new file, tsconfig JC. Let's come into our task manager, copy the configuration here, then bring it over to this one. Just paste tsconfig JC, paste everything. Now in our index TS, we can go ahead and do something like at utils / add, or let's change this utils. This is to math TS. So at utils / math, and it automatically changed. So let's go ahead. Let's add script in our package JSON. Let's say we have a couple of scripts. So the first one should be build, then TSX, then this is not a server actually, or the build option. So let's build a basic I guess we should build a basic server. But before we build a basic server, we can go ahead and install npm i-d at types / node. Okay, so now that we've installed node types for TypeScript, we can go ahead and instead of doing this, and then let's delete this one. Actually, let's delete it. And let's create another folder called server. And then in here, we can create a file, index ts. And here we can say import HTTP from HTTP, create server. What is this? Copilot is just installing things on things. So we can come over and say const server is equal to create server this hello world. Thank you, Copilot. Then we say server.listing 3000. Server is listing on port 3000. Great. So this is why let's say node HTTP. Then we can say HTTP create server like this. Whoa! So we have a basic server right now. So in here, you can come here and say import. In fact, let's move this here so that we can cover all examples with this. Delete this one, move it to trash. Now in index TS, we have our server. So we want to be able to run our server. So we have build, then we have dev, we have stats, node dist index JS. So if you come over and we'll say npm run build. Okay, so now we have our distributable folder. If you open this up, you see index.json, and we see our server here. Now, if you go ahead and run npm run or npm start, okay, node dist index.json dist source, okay. So /src /index.json. So let's clear the terminal and run it once more. We want to start our application. So let's assume we've started our application in production. So application will continue running. But we want to develop our application. So this is where TS node comes in, as we've already explained. It first of all intercepts TS files, compile it to TypeScript, and then run it. But in this process, we've already compiled this thing to JavaScript before running it. But we want TS node to handle this for us. We don't want that process of every time we want to run our development server, we'll have to first of all go compile it to JavaScript and then do that. So we can just come over and say npm run dev. And then you can see there's no emitted files. Okay, let me even delete this one so you don't think it's TS, this thing that is doing it. Let's stop this, clear the terminal, run it once more, npm run dev. And then you can see TS node dash project TS config JSON. So it's using this TS config JSON here. But even if you don't add this, it will grab the TS config JSON in the root of our project and then use it. So source index TS. So TS node is now running our project. So what happened? First of all, it intercepted our TS files. It compiled our project to JavaScript and then executed our project, and it was cached. So if you notice, when I first ran it, npm run dev, it took longer than the second time and third time because now it is being cached. So there's nothing to compile. First of all, check, have I compiled this? Yes. So just run the project. So it's happening in memory. You cannot see the emitted files. So that is TS node for you. So now we can run our project. Remember that before you run any TypeScript, JavaScript project, you must have Node.js installed on your machine. So what TS node is doing is it is not running the TypeScript project directly. What it is doing is it is basically compiling it to JavaScript before running it. So when we run npx TS node, npm run dev, first of all, it will intercept our TypeScript files, compile it to JavaScript, execute the JavaScript files, and then catch the result so that in subsequent requests, it will just serve it. Great. So we've seen how TS node works. But then we still have some issues with TS node. So we have performance considerations. So the compilation speed. So it's try-spice only. So it disabled type checking for faster startup. So it's a kind of faster, but not. So we can use SWC, but that is not the option. We can use ESBuild, which is another fast alternative. We can use SWC, which is also a fast alternative. But as you can see, if the more our project grow, the memory use we'll also consider the memory usage. So the more our project grow, the more the compilation cache grows over time. So it is being cached in memory. So it's taking part of your memory to catch the compilation result. So you can use dash. We can do something like TS node here. You can use something like dash max old space size for large projects, and we can specify the size or something like this. If you want to use TS node, or we can consider alternatives for production and all of that. So it has some limitations that will make us use TSX. So the limitations, let's just outline 5 limitations. So first one is performance. It is slower than precompiled JavaScript. The second limitation is memory. High memory usage due to compilation. The third one is production. It's not recommended for production use. 4, we have ESM, complex ESM support. That's ES module. Then 5, debugging. Source maps can be tricky using TS node. So some of these things may sound funny to you because we don't know what source maps are, compilation, blah, 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 and the rest. So it sounds a kind of strange. But don't worry, as time goes on, you understand all of these things. So why is TSX preferable to TS node? So first of all, look at the performance. So TSX is ES-build powered. So it uses ES-build extremely fast Go-based compiler. So ES-build is built with Go language. So it's faster. It's not built with JavaScript, so it's faster. So it's 10 times faster than TS node for code start. And then lower memory usage due to efficient compilation. It does not consume memory like TS node. And the second reason why TSX is preferred over TS node is better ESM support. So it supports native ESM out of the box. That is first class ES module support without complex configuration. So if you want to configure TS node to support tooling npm run dev node dev build lists. So as you can see, this is common JS. So if you want to configure TS node to support ESM, you have to do some kind of configurations and all of those complex setup. But TSX have that out of the box. So it has also mixed modules. It handles common JS and ES modules seamlessly. That is the reason why TSX is preferable. And also support top level await. So you cannot do something like await. Do this thing. You cannot do this. Now, if you hover over here, the current file is a common JS module and cannot use await at the top level. Can you see this? You cannot use top level await. Okay. So the third reason why it is preferable over TS node is simplified configuration. So it has 0 configuration. It works without TS config JSON. It automatically detects TypeScript and JSX files. So JSX simply JavaScript extensible markup language. So it's the one we're using React and all of that. So it's sensible default. It has minimal setup required and all of that. And it also have modern features like latest TypeScript. It always supports newest TypeScript features. JSX transformation, that's modern JSX transform support, and import maps, like support import maps for path resolution. So so it automatically detects TSX, TS, JSX, MTS, and CTS file extensions. So we can go ahead and say, okay, npm i-d TSX. So while it's installing, let's check out TSX, TypeScript execute. Okay, so our network is it's kind of slow. TSX. Well, in case you want to visit their website, it's tsx.is. So I don't know the reason why it's not loading. But here the full meaning is execute TSX. Okay, so now that we have TSX installed, we can come to the package JSON here and see dev. In the dev environment here, we can see TSX, and we can see source index TS. Now we can clear our terminal and say npm run dev. npm run dev, and our dev server is up. So we can even cancel this. Okay, so I wanted to show you CSS something, but I don't know why it's not loading. So I quickly want to show you Okay, so as we were saying, TSX is just Node.js for TypeScript. So the same way you use Node to run JavaScript files is the same way you use TSX to run TypeScript files. So it has features, seamless TypeScript execution, seamless CJS to ES module import, and the rest. So this and all of that. So if you scroll down, there's compilation, and this is where you come across PKG row. So this PKG row, it is a recommended bundler to project using TSX. It's developed by the same author and used to compile TSX. So if you come over, you see the basic setup, this dual package manager and all of that, command line, this and that. So we have PKG row here. You can even, let's try to open it up and see what you got. So we can install it as a development dependency. We can go ahead and do something like npm i-d pkg row. So once more, I guess our network is slow, but while it's installing, let's come back to TSX and let's look at in a package JSON, we have export this / index mjs and all of that. Start your entry point. So this is the entry point. Source directory, dual package. So you can set up both for ES module and CommonJS. So in the export, you can set the require here, which is for CommonJS, and you can set up import, which is for which is for ECMAScript modules. So we can come over to, let's just copy this thing here. I'll just copy this one here. Exports. We're not supporting dual this thing. Come over here. Our package JSON. Oh, let's just add it here. Add a comma. Index NJS. Let's say index JS. Dist src/index JS. Then we'll add a script. The build here will be pkg row, like this. So let's try to build our project once more. npm run build. So there's an error. Build. Okay, npm run build. So warning, ignore file outside of this directory. This index.js, not this one. Error, no entry point found. Okay, so I guess let's look at how we can set the entry point for PKG row. May command line being this build PKG row. Or you know what, let's do the recommended with npx PKG row, like this. Oops. Oh, okay. Ignoring files outside of this directory, error, no entry point found. This, so I've actually forgotten the configuration for this, and the documentation here, it's not the build directory and the see. This is the setup. Okay, so let's just go ahead and look at it here. Typescript, the main, we have the main scripts. Types. Okay, so I don't want us to go over doing all of these things. That's just it. But if you want to bundle with PK0 using TSX, that's fine. You can look over the documentation and go ahead and do that. But that is time consuming because I just want to show you how to use TSX and PK0. So now that we've seen how we can use TSX and PK0 with TS node, I guess we should move on. So moving on, we have building and bundling for production. Okay, so what is building and bundling? So building and bundling are essential processes in modern web development that transform your development code into production-ready assets. So understanding this concept is crucial before diving into specific tools. So we'll first of all look at the building process. And under the building process, we have compilation, optimization, and asset processing. So for compilation, we'll first of all compile TypeScript to JavaScript. So we'll convert TypeScript code to JavaScript. And under compilation, after converting TypeScript to JavaScript, we have syntax transformation. So it transforms modern JavaScript to browser compatible code. And also JSX processing, that is for front end. It converts JSX to JavaScript function calls and type checking, validate types and catches errors. So for optimization, we have a minification, we have date code elimination, we have constant folding, and we have compression. So for minification simply means removing white space and shortening variable names. So we also have dead code elimination, which removes unused code. So which is also known as tree shaking. Constant folding evaluates constant expression at build time. That's but not the least. Under optimization, we have compression. So it compresses files into smaller sizes. So if you want to build and push to production, it will build and compress files into smaller sizes. So for asset processing, we have file copying. It copies static assets to output directory. It optimizes images, compresses and optimizes images, also generates different image formats. So for front end, there's also CSS processing. So for auto prefixing, minification, and processing and all of that. So moving on, we have also the bundling process. Now, the bundling process, under bundling process, we have module resolution, module transformation, and bundle generation. So under module resolution, we have dependency analysis. So it analyzes the import/export statement. It constructs a graph. It builds dependency graph of all modules. Then it tries to detect if there's a circular dependency. So if there are circular dependencies, it identifies and handles circular imports. So I guess you should write them down. Circular dependency, you would like to know the meaning. It's a process where a file imports a module from another. Let's say a module imports another module, and that module also depends on a module from the module that just imported it. So it's circular. And also external dependency handling. So it manages third-party libraries. Like for instance, you want to handle authentication, and you install bcrypt.js. So it will handle that for you. And then the second, we have module transformation. So module format conversion. So it converts between ESM, CommonJS, AMD, and UMD. So the thing here is, it depends on what you specify. If you specify it to be converted to ESM, it should do that for you. If you want it to convert TypeScript to CommonJS, it will also do that for you. So it also processes import/export, which transforms module syntax. So dynamic import handling as well. It processes code splitting point. So this dynamic import handling, there's what we call code splitting. So that is a point where you only import code where you need it, so that your app will be more efficient. So it's just the basic definition of code splitting. That's using code only where you need it. And the other module transformation, we have tree checking, which removes unused exports from modules. Now the third third item under the bundling process, we have bundle generation. So after doing all of these things, under bundle generation, the first thing is chunk creation. So it splits code into logical chunks. The second thing is code splitting. It separates vendor code from application code. The third thing is hash generation. It creates content-based hashes for caching. And then the fourth thing is source map generation. It creates debugging information. So why building and bundling is necessary? So for browser code, ES5 support. So old browsers need ES5 JavaScript, like old versions of Internet Explorer, Firefox, and the rest. So polyfills. So it adds missing features for old browsers. The module system. Browsers historically didn't support ES module. So it will make code ready for browser that doesn't support ES modules. And the second thing second item, the second reason why we need building and bundling in applications, that is why they are necessary. So the second thing here is that they perform optimization. So I mentioned something earlier about HTTP request. So bundling reduces network overhead. Then smaller file sizes. So minification reduces bandwidth usage. So if you have smaller sizes on request, they will be served quickly than bigger file sizes. Then we have caching. So hashed file names enable long-term caching. So we also have lazy loading. Code splitting enables progressive loading. So what we mean by progressive loading is you only need a piece of code only when you need it. So maybe you are lazy loading a file or a module. So that file will be loaded only when it's needed. Great. So the third reason why we need why bundling and building and bundling is necessary, because of the development experience. So modern syntax. So developers use latest JavaScript, TypeScript features, and will organize code with imports and exports. So front-end developers also need hot reloading, instant update during development. Not only front-end, even the back-end developers like yourself. So if you use TSX and TS Node, it watches for the index.js, the entry file, so that if there are any changes, it will restart automatically for you. Then the development tools, we have source maps, debugging, and error reporting. So we have, when you want to build, you can build for development and for production. So TSX handles that under the hood. For development, you will not see the output, the distributable file, but it's doing that in memory. So the characteristics of development build, we have fast compilation, source maps are included, no minification, hot module replacement, and development server. That is the development build characteristics. Then for production build characteristics, we have thorough optimization. Minification is enabled production, tree shaking, code splitting, and asset optimization. So for modern build requirements, this includes TypeScript support, modern JavaScript features, framework integration, and all of those things. So we also have things like bundle analysis, if you want to specifically analyze your bundles before pushing to production and all of that. So basically, this is the reason why we need building and bundling. So this is all grammar for you. I know you will feel all these are not necessary. What do we need? Why do we need to bundle and build? It's just because you've been building a 10-page application, 2-page application, 5 endpoints, 10 endpoints. When you start building application with 100 API endpoints, 500, 1,000 API endpoints with 10,000 files, 500 files, 1,000 files, there you will know why you really need all these things. You will be frustrated if you don't use any of these. Okay, so now we understand what building and bundling is all about and how it makes our lives easier. Great. So moving on, we have tools. And these tools, we have first on our list, we have Webpack, we have ESBuild, Rollup, Roll Down, and TS Down. So I believe we don't really know what all these are. So the first on the list is Webpack. Okay. What is Webpack? The first question that should come to our mind, because some of us don't know what Webpack is. So Webpack is a static module bundler that has dominated the JavaScript ecosystem since 2012. Yeah. So it treats everything as a module and builds a dependency graph to bundle your application into static assets. So the core concept behind Webpack is one, the entry points. So entry points define where Webpack start building the dependency graph. So in our case, the entry point is our index TS file. So Webpack will start from there. We build, bundle, and build our dependency graph and all of that. So we're mentioning other terms like dependency graph, blah, 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 and all of that. So it's your responsibility to find out what module graphs are and other things we've mentioned that you don't know. Just write them down and find them out yourself. So we can go ahead and explain everything in details here. So we have the output. Now the output defines where and how Webpack emit bundled files. Now Webpack also has loaders. So loaders transform files from different languages to JavaScript. So let's say CSS, other JSX and everything. It transforms everything to JavaScript. So we also have plugins. So plugins here like HTML. We have HTML Webpack plugin that handles HTML bundling and everything. So in Webpack, you can configure Webpack to support TypeScript use different loaders for different things to make your code ready for production, bundle both HTML, CSS, and everything, transform them into JavaScript and make your code production ready. So if you want to use Webpack, you can head over to their website, read your documentation, and see how you can optimize your code for production and support every other thing. So Webpack have some strengths. And the number one strength is its mature ecosystem. It has a mature ecosystem. So it has some extensive plugin system, large community, framework integration, and enterprise adoption. So the second strength of Webpack is comprehensive features like asset bundling, code splitting, hot module replacement, and development servers. It is also flexible. So under flexibility, you can do something like configure. It's highly configurable. You can have multiple entry points, custom loaders, plugin architecture, and all of those things. But it also have some limitations. So performance issues. So under performance issues, we have slower build. So if your project grows, it starts to grow. You see that the build, it can be slow for larger projects. And the memory usage becomes high memory consumption. And initial build, let's say you have a project of 1,000 files, all of that. If you want to build it, it will take time. And let's say you want to start your development server, it takes a couple of minutes instead of seconds. And configuration complexity, if you want to configure Webpack, it's a whole lot of something on a different level. Okay. So now we understand Webpack. All these things, no examples for Webpack, no examples for all these other ones. And when we get to tears down, we can see how we will do that. But apart from Webpack, we have another one on the list here. We have ESBuild. So what is ESBuild? So ESBuild is extremely fast JavaScript bundler and minifier written in Go. So it's designed for speed and handles TypeScript, JSX, and modern JavaScript features with minimal configuration. So ESBuild is excellent for development. So the speed is real fast. It's Go-based and it's utilizing parallelism and efficient algorithms for development. It's 100 times faster than Webpack for typical builds. And it's 10 times faster than other fast bundlers like Parcel. We have other bundlers that we did not mention. What you need to know is ESBuild is extremely fast and it's faster than all of them, if I should say. Except roll down. I will get to roll down in a bit. So it has a built-in TypeScript support as well. I mentioned this earlier. ESBuild has built-in TypeScript support and has development-friendly features. Also minimal configuration. So no examples for ESBuild, no examples for Webpack. Moving on, I just want to show you the reason why I'm trying to explain all of this so that you know the reason why we're not using Webpack, we're not using ESBuild, we're not using Rollup, we're not using Rolldown. And remember that I mentioned something about development builds for ESBuilds, but not production. So in production, you have to use other tools to make your code production ready because ESBuild has some limitation. So for ESBuild, there's no type checking. It only strips type. It doesn't validate them. So limited CSS, basic CSS support, but no advanced processing. Plugin ecosystem. It has a smaller plugin ecosystem than Webpack. And bundle splitting. So for the bundle splitting, it is less sophisticated than Webpack. And it has limited legacy support for like old browsers. So that brings us to Rollup. So what is Rollup? Rollup is a module bundler that specializes in creating efficient, optimized bundlers for production. Can you hear that? Okay, so before we even talk about rollup, let's first of all read a little about ESBuild. ESBuild is an extremely fast JavaScript bundler and minifier written in Go. So it's designed for speed and handles TypeScript, JSX, module, blah, blah, blah. But it's suitable for development, and we'll see the reason why in just a bit. So Rollup is a module bundler that specializes in creating efficient, optimized bundles for production. So it's pioneered tree shaking and ES module bundling, making it ideal for libraries and production applications. Why Rollup excels in production? So the first reason why it excels in production is its superior tree shaking. So you know that tree shaking is elimination of dead code. So it removes unused code at the statement level. There's where you state like something, let something there. It starts from there. So when the code is not used, that is where it will remove it. ES module analysis. It leverages ES module static structure. Then it bundles your code into smaller chunks, produces the smallest possible bundles. It also supports ESM out of the box, native ESM support, library optimization, and all of that. Plugin ecosystem is also great. So Rollup is good for production because of that, because ESBuild, when it goes to code splitting, minification, and bundling, ESBuild needs some plugins to do that for you. But Rollup, you don't need any plugins to do that. But it has some performance characteristics here. It is slower than ESBuild, approximately 5 to 10 times slower than ESBuild. But it is good because it's performed deep code analysis for optimization. It also have incremental build support, watch mode for development. And its bundle quality is smaller, smallest bundles, optimized structure, and production ready. So you don't need to worry about all of those things. Okay, so now comes in roll down. Now, roll down is written in Rust. Remember I mentioned that ESBuild is written in Go and roll down is written in Rust. And you may be asking that if all these are written in different programming languages, why are they used in JavaScript? So this is what we call WebAssembly. So after all of this, you build your code and you can use the WebAssembly to link another programming language to JavaScript, and it will work as if everything is written in JavaScript. So all these things are faster because Go and Rust are fast programming languages. Should I say they are compiled? Rust, I don't really know about Go, but Rust is a compiled language. So roll down is actually called the game changer. So it is designed to bridge the gap between development speed and production optimization. So before roll down, we use ESBuild in development, ESBuild and Vite. That is for front end, but for back end, you can see that TSX is written with ESBuild. But when it's for production, it uses PKG rule, and PKG rule uses rollup and parcel, I guess. So using two different tools for development and one for production is not that efficient. So that's where the roll down steps in. So roll down is Rust based, and it is written by void zero. Okay, so this should work now. Void zero. So some of these you should just have an idea about them. And look at V0, next generation tooling for JavaScript. Our mission is to make web developers more productive than ever before. So if you look at the project here, we have Vite, a build tool for the web. We have Vitest, next generation test runner. while roll down, the fastest JavaScript bundler, and it is not a lie. They were fastest JavaScript language to chain, OSX. So all this is engineered by Evan You. Evan You, the founder of Vue.js. So these are their tools for now. You can see their stars on GitHub and contributors. So all these are open sourced. So roll down is Rust based, written in Rust for maximum performance. It leverages Rust's excellent concurrency. And Rust is also memory safe. So it leverages the memory safety of Rust to prevent common bundler crashes. So rollup compatibility, it aims to support existing rollup plugins. And what makes Rolldown super powerful is similar API to rollup for easy migration and configuration, familiar configuration patterns. So if you're migrating to Rolldown, you don't have to read any documentation for anything or all those things. So it's for development and production. First, fast development, ESBuild level speed for development. It's speed, it's up to that of ESBuild. And production optimization, roll up level optimization for production. This makes roll down a game changer. So unified tooling, one tool for both environments, both for development and production. There's no need to use ESBuild for dev and roll up for production. So modern architecture, incremental compilation, smart caching and incremental build, hot module replacement and source maps. Everything we mentioned that one has and the other doesn't, roll down supports everything. Current status, it is in beta. So it's a software in beta. So it's in actual active development with the following status. So when I say it's in beta, I mean beta release. It's available for testing and feedback. So its core features, basic bundling and transformation that are working, plugin system, partial rollup plugin compatibility, but it's actively being worked on. So you can migrate and do all of that, but it is not advisable to use roll down for now. And that is why the Voice Zero team decided to go out of their way to bring us TS down. So TS down was launched in January 2025 because I guess that was, okay, let's check it out. So here we have TS down, the elegant library bundler powered by roll down, as you can see. So brought to you by Void Zero. So if you come over here, you can see the documentation. So why Tears Down? Tears Down is built on top of Roll Down, a cutting-edge bundler written in Rust. While Roll Down is a powerful and general purpose tool, Tears Down makes it a step further by providing a complete out-of-the-box solution for library authors. So key difference between Tears Down and Roll Down: simplified configuration, library-specific features, feature-ready, everything. So if you come to now, we have options, the configuration options. First of all, we'll come to our project here and we will eliminate everything in here. Let's remove PK0, TS, Node, TSX, and all of these ones. Let's remove this. Then let's look out. Let's say npmi-d TS down. Let's use TS down. Oops. But we still need TSX for development. I shouldn't have removed TSX. So coming here, we have clean watch mode. So you can use it for your development server as well. Or that's by the way. Now that we have tears down, installed. Oops. Compare. Okay, let me just mark this. Go ahead and do this. So here is TS down version 0.12.9. So if you come to our build here and say TS down, now we need to specify, we need to configure TS down, say TS down.config TS. So let's go back to the documentation and see how we can configure TS down. Now, first of all, let's copy this, bring it in here. So our entry point is entry source index JS. So by default, you can come over here and say clean to true. But by default, TS down handles this for us. It handles cleaning the existing distributable folder for us. So we can come over and say npm run build. And this completed in 41 milliseconds. This index MJS. Now, if you come over here, open this, then you can see. This is our JavaScript file, and everything here it's actually optimized, but not minified. Now, if you come over to your TS down config TS, you come over here and see output directory should be dist. If you don't want it to be dist, you can say it should be build. If you don't want to name it distributable, say build. And then if you run this once more, you will see that we now can delete this dist distributable, and we now have a build folder. If you open this, the same thing is inside. Okay, now if we come over and say format, which format? We want both formats. We want both CJS and ESM. Now let's go ahead and do this once more. npm run build. Now if you open build, you see index NJS. This is ES module. And if you open index.js, this is CJS, common JS. So we are now building for both common JS and ESM. But that's not what we want. We only want ESM. So instead of specifying an array, we can say ESM, not an array. Now if you come over here and do this once more. So every time it will remove the old directory and build another one for us. So we don't have to do that manually. Now if you open index.js, now we have this thing. Okay, so let me come back here and add some comment. Now let's go ahead and build this once more. npm run build. Let's open this. We have the comments. Great. So if you want to look at the options, we have config file, declaration, output format. We have ESM, CJS, and immediately invoked function expression. So whichever you prefer. The output directory. So it is telling you that bundle your code into this directory. This is the default one, which we've been seeing. But you can specify it to be build or anything. We have cleaning. And by default, TS down will clean the output directory for you. And dependencies and all of these things. You can come over here, mark things as external. Try to go through the documentation. We have the watch mode, we have the target. So we can specify, if we specify our engines to greater than or equal to node 18, we can set the target. Target is what? Yes, this is that, this, that, and all of that. We have platform. So are we building for node or we are building for browser or neutral? So we can come over here on our, we're on the server. Okay, Copilot, let me make you happy. So we're on the server, so we can come over here and see, not target, platform. And let's say node, because we can make it neutral so that our code can both work on the server side, on and browser, but let's make it a Node. Okay, so now tree shaking occurs automatically. Let me do something like const name is equal to some name. Okay, npm run build. Open this up. Can you see one surprising thing? So this is tree shaking in action. So there's something here that we did not use, this name here. And you can even include it here. You can say, okay, plus name. And now remember, okay, let's do this once more. npm run build. Come over here and we see our name. It's here because the bundler noticed that we used the name over here. Now let's come over here and remove this thing. And now it's just like, tree have dead leaves and the leaves that are still green, the green ones. So now the bundler knows that, okay, this one here is a dead leaf. Oh, compiler, stop disturbing. So here is a dead leaf because it is not used anywhere. So if you go ahead and run this, before we run it, look at the NGS file again. Look at the name, look at where it's used. Now let me run it once more, npm run build. Now take a look. It has been removed. That is tree shaking. Unused code is being removed. Great. So I believe you don't know what minification is. If you look at this, we still have all this server, all these long variable names and the rest. So, and the spaces here, we still have spaces. So let me show you something. If you come over here and say minify, and we set to true. Now, if we run, let me just focus on the file. Look at the file here from npm run build. See what happens. Bah! Look at how our code looks now. Look at the names, the variable names, just ET to no long server or anything. The code is being minified. If I run it once more, everything is on the same line, no separate lines. There's no something like a space, or it is minified and bundled, and our code is now optimized for production use. And now let me show you another thing. Let's say we have add tiers. Now I'll come over here and see export add. Export function add number return this. Now come over here and say plus add like this. Now let's go back to index.mjs and I run npm run build. Now let me format this. Now look at what is going on. Everything is in a single file. Everything is in a single file. So if you have 1,000 files, everything will be compressed and will be brought into this index.mjs and nowhere else, because, and we can go over here and then say, okay, we don't want it to be minified. Now say npm run build once more. Open our index.mjs file, and then we can see now we have the region for source/rts. This is it. We have the end region for it, and we have the star region for index.ts, and this is where it is used. Now we have all our variable names complete. But by the time we say, oh, bro, we need you to minify this for us, we want our server to be optimized and to be fast as possible. If you run npm run build, open index.mjs, and then we have this ugly code over here. And that is the reason why some code, you see some production code, you won't be able to read them, because that is why they are called the distributables. And the T and the parameters are also just single letters, no long name, N, E, N, and all of that, T, 2, 3, no. This is 3 exponential 3. 3 exponential 3 means 3 times 10 to power 3. That is 3,000. But 3,000 actually. So we have other options that we can specify. And now if you come back to our TS config JSON, so it doesn't even care about the TS config, but we can come over and set our module resolution to bundler, because we're using a bundler now, right? So we allow the bundler to take care of everything. But it doesn't even care. And look at how fast it is. Using TS down configuration from here, entry point source index.js. The TS config is located here. Build start, cleaning one file. Cleaning one file means it is removing this build directory. Then moving on, one file total 0.2 kilobyte, build complete in 39 milliseconds. Imagine how fast it is. Module resolution bundler. Bundler can only be used in preserve. Okay. Preserve here. And we are good to go. No more error. Great. So this is tears down in action. So essentially, if you come over and say, oh, I want to build for CJS, then run this, boy, 109 milliseconds. If you open your build index.js and you see this is CJS, this is no longer ESM, but you can see that the variable names are short, no spaces, everything on a single line. I just formatted it to be on different, so we can see what we've got. Great. So this is tears down in action. So tree shaking, source maps, minification, dash minify if you're using it on a command line, silent mode, shims, package export, unbundle. So essentially that is it. So in essence, what I'm trying to say is, okay, so now we can come over here, not there, not there, not there, please. So we can come over and say, okay, npm run. So coming to our package JSON file, you can say our start command is a build / index njs. Index njs, npm start. Okay, module not found. It's index.js because this is CJS. Our server is up and running in no second. Great. So this is in production, but in dev, npm i -d tsx. In dev, we can say dev tsx, and then we say npm run dev. Our server is also up and running. So this is in development. This one is in production. So we look at what we're pointing in here, build index.js. So in our node modules, if you have git ignore, in here you say, okay, ignore node modules and ignore the build directory. And now you see them, they are ignored. So if you add this to your GitHub or anything, all these things are ignored and they will not be added, because when you run npm install, the node module directory will be generated automatically. And if you run npm run build, this one here will be generated automatically. So this is basically for, if you remove this format and run npm run build, open this, and you see it's default to ESM, that is ES modules. So this minimal configuration, and it's very, very powerful. Now we've specified the entry points, so it will start bundling from there. But by the time we come and specify the entry point to be add TS, and we run npm run build, and if you open this, we have add NJS, and this is the only thing being built but if you specify the entry point, everything that is being imported inside of that file will be bundled. So if you have an index TS file, every other thing you've built, if you have 1,000 files, 1,000,000 files, everything leads back to that index file. So it will start bundling from there and build a module graph down to all the files being imported, all the API endpoints and everything will be bundled. Great. Wow. This has been fun. I hope I've not blown off our heads. So I wanted us to actually convert part of our app to TypeScript, but it's not even necessary because we've already understood what's happening here and we're out of time. So if you have any questions, you can go ahead and ask.
Yeah. So it has been a roller coaster of lectures.
I'm sorry, you said?
I said it has been a lot. Like you've said a lot. So probably someone would have to like watch the video again and digest all of the lectures again. But I have a question. Can you hear me?
Yeah, I can hear you. Go ahead.
Okay. Yeah. So I know that the likes of Vite or Webpack, they are more of for build a tool for the front end.
Yeah.
So, but is there any distinction between all of these other ones like the roll up, roll down, TS? Is there any distinction? Is it just for, can we use it for front end as well and as the back end project? And then the second question is for this type TS down, can we use it for normal JavaScript project so that we get all of this function, all of its functionalities like Mimify, like trick shaking. Instead of using it for TypeScript projects, can we use it for uh, normal JavaScript project?
Yes, you can use it for JavaScript. You can if you want to use it for JavaScript, all you need to do is come over here, change this to JS, and you see we have no errors. Change your entry points to JS. Now come over here to the entry points. Change this to JS. Now in the entry point, remove the add. Remove this and this. And run npm run build. If you open our index.mjs, everything still works as expected.
Wow. Wow.
But by this time around, it knows that your project is JavaScript. It is not TypeScript. So there's no need for it to actually compile from TypeScript to JavaScript. So it will directly bundle, minify your code, and then do the necessary optimizations.
Okay.
And for Webpack, you can use Webpack for both front end and back end. For front end, you need extra tools. Like you have Vite. There are these transformation and all of that. So if you are using a development server, the reason why Webpack became slow is if you are building and you are developing, you have, before your code will run and show up in the browser, first of all, let's say you have 1,000 files. That's 1,000 modules. So when you save that file, Webpack will have to invalidate the cache, reload, and then balance everything. You have to, okay, this file has changed. So we have to reload this project and we have to bring everything together so that the changes will be applied. But what Vite will do is, Vite we say, okay, we have a graph. Let's say we have a graph here. A graph. Nope. So this graph, then we have J. Okay. So this is the entry point, which is I. So if anything changes in I, Vite will just pick that change, invalidate the cache at that point, and then apply that change only where it changed. So let's say this is the graph. We have the left and the right. So if anything changes on the left, Vit has nothing to do with what is on the right. So it will come here, apply the change here, then invalidate this part, and then that part will be applied. Everything else stays the same. So that is what makes it fast, and it's not built in JavaScript. It's built in Rust. It's written in Rust. So that's what makes it fast. But Webpack is typically written in JavaScript. And it's just JavaScript extensible markup language. So Vite comes in. So Vite will do that, and tears down will take, but really need things like Vite, and for this one, tears down is okay, but Vite, and you need other things for bundling. But you can also check that out and see the difference. So okay, so in absence of any other questions, we can call it a day.